So this problem wants us to maximize z equals 5x minus y over the following constraints. 3x plus y is less than or equal to 9. X is greater than or equal to 0. Y is greater than or equal to 0. So let's graph the bottom two lines first. Those are easier. X is greater than or equal to 0 is actually the y-axis, and we're going to shade it all the things greater than it to the right. Y is greater than or equal to 0 is actually the x-axis, and we're going to shade everything above it. Those are all the y's greater than or equal to 0. Now, in order to graph 3x plus y is less than or equal to 9, we can either find the intercepts or we can just isolate y. So I'm going to do that. We're going to subtract the 3x from both sides, and we get y is less than or equal to negative 3x plus 9. So let's go ahead and graph this. It might not fit perfectly on our graph. Our b is 9, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 up here. And we are going down 3, 1, 2, 3, and over 1, down 3, and over 1. And this gives us this line here. Now my line is a little bit wavy, but basically it's going to give us this line here going through that. And we need to shade below it, so our feasible region is actually this region here. Now, in order to maximize the function, we have to find our three corner points, 1, 2, and 3. And in this particular example, they happen to be easy to see. Hopefully your graph is a little bit prettier than mine. One of them is the point 0, 0. That's our origin. One of them is going to be the point 3, 0. That's this point down here where our line meets the x-axis. And then the last point is the point 0, 9, which is this point up here where our line meets the y-axis. So all we need to do now is go back to our optimal function and plug in each of our points. So we're going to find our z. So we've got 5 times 0 minus 0, which just gives me 0. Here, when we plug in 3 and 0, we get 5 times 3 minus 0, which gives me 15. And here we get 5 times 0 minus 9, which gives me negative 9. So when I look at the values that my three corner points give me, since I want to maximize the optimal function, that's the largest value, which is 15. And so in order to maximize the function, we maximize it at 3, 0, and the maximal value that we get is 15. If it had been a problem looking to minimize the function, it would be the 0, 9, and the negative 9. But since it wants to maximize the function, we go with the point 3, 0.